In most languages, we attempt to assure that our code is correct by using test-driven development, where as developers we will start by writing a test of something and then write the code to make it pass. If we're really sophisticated, we may use something like a quick check type tool to do property-based testing, where we can actually say not just that there is a specific case for which it passes, but we can generalize that over many different cases. In Elm, and as a member of the ML family, we can do something more. We still should do all those things. But we can also use our type system as a design tool. If we're a little bit clever, we can ensure that the invariants in our code that we want to be correct will happen not because we have a test of it, but because we've defined a type for it. So what do I mean by that? Well, for example, take a list that you want to iterate through. For example, a carousel on a web page. The sort of naive way to build that would be to create a list of elements and then have an integer that tells you which one is the current one. So number 6 is the current one that you want to look at. The problem with this is that it is possible that it says the current element is number 6, but oh, there is no 6th element. And that's an error, obviously. And if we design our types with the theory of list of elements and pointer, you could have an index out of range error. And it would still type check. But what if we did something different? Like say we had a data structure that had a list of elements before the current element, and a list after the current element. Well, this solves the problem of an index out of range error in that we don't have an index, so it can't be out of range. And it also means that we can never have an empty carousel. You can imagine if you have an image carousel like you see on many e-commerce sites, but somehow the data never loaded, well, then you have a problem because, well, what happens there, that could still be valid. The code could think it was valid, but it's not. So if we use our type system to design that, then we can ensure that only valid code executes and that we don't have to write a test for it, or the tests we write for it are much simpler because the type system itself serves as a test. In a type language like Elm, and this is a radical change if you're coming from JavaScript or Ruby, you can use the type system as an assurance of code correctness in addition to a unit test. And in fact, it's a better assurance because a unit test says there exists one possible case for which this code is correct. Whereas a type says, for all possible cases, we know this code to be correct. So that there is no special value that we never thought of that says, oh, look, this thing's going to blow up. And that's really, really nice. You can say, for all possible values, we know the code will work. So that is a really powerful thing in Elm, and should be considered heavily.